For any help regarding probabilistic systems analysis homework help visit https://www.statisticshomeworkhelper.com, email info@statisticshomeworkhelper.com, or call us at +1 678 648 4277. For any help regarding probabilistic systems analysis homework help visit https://www.statisticshomeworkhelper.com, email info@statisticshomeworkhelper.com, or call us at +1 678 648 4277. Probabilistic Systems Analysis. Problem. Write your name, your recitation instructor's name, and TA's name on the cover of the quiz booklet and your 2 blue books. Include the question number on the cover of the blue book. Problem. Each of the following statements is either true or false. There will be no partial Craig dividend for the true-false questions, thus any explanations will not be graded. Please clearly indicate true or false in the below. Ambiguous marks will receive 0 credit. All questions have equal weight. Consider a probabilistic model with a sample space omega, a collection of events that are subsets of omega, and a probability law P, defined on the collection of events, all exactly as usual. Let A, B, and C be events. A if P, A, less than or equal to P, B, then A subset of or equal to B, true false, B, assuming P, B, 0, P, A, B, is at least as large as P, A. True false. Now let X and Y be random variables defined on the same probability space omega as above. C if E, X, E, Y, then E, X2, greater than or equal to E, Y2. True false. D, suppose P, A, 0. Then E, X, equals E, X, A, plus E, X, AC. True false. E if X and Y are independent and P, C, 0, then Px, Y, C, X, Y, equals Px, C, X, Py, C, Y. True false. 1 2 C2, F, if for some constant C we have P, X greater than C, equals, then E, X. True false. In a simple game involving flips of a fair coin, you win $1 every time you get ahead. Suppose that the maximum number of flips is 10. However, the game terminates as soon as you get a tail. G, the expected gain from this game is 1. True false. Let X be a uniformly distributed continuous random variable over some interval a, b. H, we can uniquely describe fx, x, from knowing its mean and variance. True false. Let X be an exponentially distributed random variable with a probability density function. Fx, x, equals E minus x. I then P, 0 less than or equal to x less than or equal to 3, 2 less than or equal to x less than or equal to 4, equals 1 minus E minus 4. Let X be a normal random variable with mean 1 and variance 4. Variable with mean 1 and variance 1. J, P, x less than 0, P, y less than 0. True false. Let Y be a normal random. True false. Problem 2. Please write all work for problem 2 in your first blue book. No work recorded below will be graded. All questions have approximately the same weight. Borders Bookstore has been in business for 10 years, and over that period, the store has collected transaction data on all of its customers. Various marketing teams have been busy using the data to classify customers in hopes of better understanding customer spending habits. Marketing Team A has determined that out of their customers, 1/4 are low-frequency buyers, i.e., they don't come to the store very often. They have also found that out of the low-frequency buyers, 1/3 are high spender, SI.E. They spend a significant amount of money in the store, whereas out of the high-frequency buyer, 1/10 are high spenders A. Sum each customer is either a low or high frequency B. Unit each customer is either a high or low spender. A. Compute the probability that a randomly chosen customer is a high spend.er. B. Compute the probability that a randomly chosen customer is a high frequency behavior, that he/she is a low spender. You are told that the only products Borders sells are books, CDs, and DVDs. You are introduced to Marketing Team B, which has identified 3 customer groupings. These groups are collectively exhaustive and mutually exclusive. They have also determined that each customer is equally likely to be in any group. Customers are I.D, independent, and identically distributed, and each customer buys only one item per day. They refer to the groupings as C1, C2, and C3, and have determined the following conditional probabilities. P purchases a book, customer in C1, equals 1/2 P, purchases a CD, customer in C1, equals 1/4 P, purchases a DVD, customer in C1, equals 1/4 P, purchases a book, customer in C2, equals 1/2 P, purchases AC, customer in C2 equals 0 P, purchases a DVD, customer in C2, equals 1/2 P, purchases a book, customer in C3, equals 1/3 P, purchases a CD, customer in C3, equals 1/3 P, purchases a DVD, customer in C3, equals 1/3. C. Compute the probability that a customer purchases a book or a CD. D. Compute the probability that a customer is in group C2 or C3 given he/she purchased a book. Now, in addition to the data from Marketing Team B, you are told that each book costs $15, each CD costs $10, and each DVD costs $15. E. Compute the PMF, expected value and variance of the revenue, in dollars, Borders collects from a single item purchase of one customer. F. Suppose that n customers shop on a given day. Compute the expected value and variance of the revenue Borders makes from these n customers. The following question is required for 6.431 students. 6.041 students may attempt it for extra credit. Skipper is very abnormal, not that there's anything wrong with that. He doesn't fit into any of the marketing team's models. Every day Skipper wakes up and walks to Borders' bookstore. There he flips a fair coin repeatedly until he flips his second tails. He then goes to the counter and buys one DVD for each head he flipped. Let R be the revenue Borders makes from Skipper each day. G. What's the daily expected revenue from Skipper? What's the variance of the daily revenue from Skipper? Problem 3. Please write all work for Problem 3 in your second blue book. No work recorded below will be graded. All questions have approximately the same weight. We have S urns and N balls, where N greater than or equal to S. Consider an experiment where each ball is placed in an urn at random, i.e., each ball has equal probability of being placed in any of the urns. Assume each ball placement is independent of other placements, and each urn can fit any number of balls. Define the following random variables. For each I equals 1, 2, for each k equals 0, 1. Comma, let xi be the number of balls in urn I. And let yk be the number of urns that have exactly k balls. Note, be sure to include ranges of variables where appropriate. A. Are the she's independent? Yes or no? Please explain your answer. B. Find the PMF, mean, and variance of she. I.e. compute PXI, K, E, XI, and var, XI. C. For this question only assume N equals 10 and S equals 3. Find the probability that the first urn has 3 balls, the second has 2, and the third has 5. I.e. compute P. X1 is equal to 3 intersection X2 is equal to 2 intersection X3 is equal to 5. D. Compute E, YK. E. Compute var, YK. You may assume N greater than or equal to 2K. F. This problem is required for 6.431 students. 6.041 students may attempt it for 5 points of extra credit. What is the probability that no urn is empty? I.e. compute P, X1 greater than 0 intersection X2 greater than 0 intersection XS greater than 0. Each of the following statements is either true or false. There will be no partial credit given for the true-false questions, thus any explanations will not be graded.